So a warm welcome to the day 3 of this session. Please continue, Tejas.
I must also close my file, and now I'm added my file. See this one very carefully. So I'm get the full adder, all of you. So from the yesterday class we are done up to here. See this one, but now I did not create the project. I'm open the project. I'm open my previous project. Okay, yesterday what I'm giving the name. So this is the command of open project, and this is the command of the create project. Okay, all of you. And now I'm continuing from there. We have to set the top module for the full adder. We have to set the top module. This is, we are adding the files into the top module like this. See you. So we are set the top module only. We are adding the files into the design source, and now I'm set the top module. Set property top. So now you can give this name, the top module name. Sir, why we have to give this top module name? Is it mandatory? Is it mandatory? Yeah, definitely it was mandatory. See, suppose we are doing the full adder using half adder. Suppose if, for example, we are using, we are doing the program of full adder using half adder. So definitely we have to write the code of module FPGA like this. We have to use the HAM 2 times. So this kind of syntax of code, correct or not? But my main module name is FPGA. My HA name is the submodule. Okay, HA name is submodule, but my FPGA name is top module. Okay, you need to give the top module name, all of you. So definitely the TCL scripting was recognized that. So you need to give the top module name. So I did not use any kind of module instantiation here. So for simple programs, my top module is full adder. So that's why I'm writing the command of set property top full adder. So current file set of this current file set. Okay. So this is the command of the set property and this one. Okay. So up to here, this is related to the only main code, only the design code, what we are understand actually. This is only related for the design source code. See this one. So we are completing the full adder code. This is only for the related to the design source code. So now we will check the synthesis. There is a chance of synthesis checking. We need to check the circuit. Sir, is it possible to check the circuit? Yes, it is possible, but not with image representation. In TCL, no image representation. Yesterday I was told that. Okay, image presentation only they are giving. But how can we recognize the output, sir? How can we recognize the output? They are giving the reports. They are giving the reports. See, I'll show it. How can we check that? All of you. I'm launch the synthesis. Launch. Just a minute. Launch run synthesis. See, I'm launching the synthesis. All of you, please see this one. Now you can write the wait on runs synthesis one. So now we are checking the reports only. Okay, how can we getting the reports? So if you get the error here, definitely there is a code error in our see, my command is here. You no need to worry about it. Okay, my command is here. Now we will check the one by one. All of you, please see this one. So they're giving the different kind of reports: RTL, partial replication, instantiation. In the report, they are giving any kind of replications or instantiation. We did not use the module instantiation. So that's why this block is empty. Okay. In this full adder code, we did not use any kind of module instantiation. I think you people are understood what I'm saying. And replications also. In the full adder code, we can use the replication also, just like this. normally just like this, you have to take the replications also, like n bit of something like 1 bit 0. So this kind of replication you have to take this. So I did not take any kind of replication like this. Okay, so that's why the replications are also empty. And now you can come into this one, RTL components. See, they're for the professional, they are using only, they are seeing only the reports. They did not see this kind of images. Okay, so in the RTL components, 3 inputs, 1 bit, and using only 1 XORs. See, 3 inputs. I mean, just a minute. I will show it in entire main part. So there is no multi-driver nets. This is a small full adder program. Yeah, here. See this one. The lookup tables. So how many lookup tables in there using in the synthesis? 2 lookup tables. One is for sum and one is for carry. Input buffers 3. So A in 1, in 2, in 3. And output buffers 2. Of course, you people are know about it very well. Some people are confusing, sir, what is this report cell use? We did not understand. See, I will show it. I will show it in main code. Just I am writing the full adder again. ABCN. Just I am writing the normal code. Sum comma carry. Just I am writing the normal code. All of you, please see this one. Sum comma carry. Assign sum is equal to. So simply this one is A cap, B cap, C in. And assign CA. Just I'm writing the normal code, okay? A cap, B cap, C in. So C in cap A. So this is the Verilog code, okay? This Verilog code. Just now I'm running the synthesis. Click on the control plus yes. See, now I'm in Vivada tool, I'm running run synthesis. So what I'm done in TCS scripting, I'll show the image, how they're giving the reports. So it will take a little bit of time. We need to wait for some time. So this is the total report cell usage. Okay, this is the cell name and this is counts, how many cells we are using. So lookup table 3. So we are using the 3 input lookup table, two 3 input lookup tables. Okay, I will explain when the output is come. So this is the total information about the synthesis. Okay. Yeah. It will be loading. In just a minute. Yeah. So all of you, please see this one. So LUT3. How many LUT lookup table 3? So 3 input. So why we can call it as LUT3? 3 input lookup table is there. See this one, 3 inputs. So that's why we can call it as LUT3. So how many LUT3 are here? How many LUT3s? 2 LUT3s. So in the reports, we need to cross check with that. So in cell usage, how many LUTs is there? 2 LUTs. How many input buffers? 3. See, this is the image confirmation. 3 input buffers. See, IBuff. 3 input buffers and 2 output buffers. So this is the reports they are given by the TCS scripting. Okay, they did not give the image representation, but they are giving the accurate reports. Okay, so I think you people are understood what I'm saying actually. So this is the very crucial thing. I mean, to check the reports. I mean, in the industry person, they are checking the only reports. They did not see any kind of image representation outputs. Okay, so now I will write the code to checking the simulations. Okay, so same thing we will continue from here. So same thing, we need to create the file mkdir. Same you can repeat with dot ladder tb. That's it. So this is the creation. See this one, all of you. So now again I'm writing the code. Just a minute. I'm already writing this code. See full add tb. So just we need to comment our see this is the tb file, full add tb file. Same address we are giving this. This is the test bench. Okay, this is the test bench. So how? So in the sources we have to create this test bench simulation source. Okay, all of you. So copy, and I'm directly pasting this test bench code. Okay, I'm directly pasting the test bench code. See this the puts dollar FP. I mean, just a minute. I was changed the name. I was changed the name here. 1 minute. TB. With the name of TB, you can change the name also. That is also not a big problem. All of you. So just for confirmation, I'm changing the little bit names. Okay. Yeah. TB. So again, close TB. That's it. So now we have to give the top module name to the test bench file also. All of you, please see these comments. Okay. So the add files. So the add files file set. This is for particularly simulation. Same repeated one. See how can we repeat it for the our main file. See, I'm repeating for the main file. You people are observed that I'm repeating the same file, add files for that. So same thing for the test bench also. Okay, same repeating process. Ladder tb. So tb.v. So this name was given here. Same. We have to copy this address here. Okay. So same. Now it will be saved that. So set property. So then what is the top module name in the test bench? TB. The TB is the top module name. Okay. You need to give the TB, just TB. Okay. Get file sets simulation 1. All of you. So this is the property of the command. Same. We need to give the top module for the test bench also. Now we can click on enter. So this is the test bench creation. Same repeated process. How can we create the main file? So same repeated process you can do with $tb. Okay, same repeated process you can do that. Sir, we have some small doubts, sir. Shall we read the files? Is it possible? Reading of the files. Suppose I want to read my main file. No, I want to read my test bench file. Is it possible? Yes, it is possible. I will show it. How can we read the file? See this one. See, I'm changing only the command. I'm replacing the W with R. See this one. I'm replacing the W with R only. Just see, now it is access this file. All of you. Now it is access this file. See this one. So puts read $tb. So here we are puts tb. So here also you can use the tb. See, now the code will be generated. given the code. So what we are written there. This is the main thing. Okay. So again, you can close it the $TB. That's it. Now we will check the simulations. Okay. Now we will check the simulations. So simply you can use the command launch simulation. So is there any error in my code? Definitely it will give the errors. It will show the errors. Okay. I'm launching the simulations. So is there any error? Definitely it will be show the errors here in this left side. So I think just a minute. Yeah, there is no errors. So this is the verification of the full adder. So I think the small program you people have so get some more clarity. So that's why I'm doing the full adder. Okay, all of you. So this is up to simulations. I did not use the hardware. I mean, I did not use the. I mean, this is not our final one. Okay, this is not our final one. So we need to connect the hardware. We need to connect the FPGA board with using TCL scripting. So that is our major point. Okay, all of you. And now coming to this one very carefully. So this is the verification just for we are done here. So again, we need to run the synthesis. Reset, run. Wait a minute. We need to run the reset run synthesis. So again, it will give the directive problem failed. Okay. So the launch runs synthesis 1. Yeah. So it will give that correctly. So we will definitely continue there. See, wait on run synthesis. We need to again do synthesis. That's it. Okay. So this is the shell count. I mean, I'm already explained this. This is the shell count of lookup tables, and of course, we are using a total 7 cells, 2, 3 plus 2. So in the top module, the circuit, this is the total 1, 2, 3, 1, 5, 6, 7. So we are using the total 7 shells. It will show it in the report of instance areas. Okay. And now coming to this one. See, additionally, we need to how to generate the reports. Okay. How to generate the reports. That is our additional thing. So all of you please see this one. See, suppose if you want the timing reports, so you can directly give this one report timing. If you want the timing reports, see, if you want the timing reports of the circuit, just timing reports of the circuit. See, if this reports, this if you want the timing reports of the circuit, so you can give this one command. Okay, there is no open design here. We are running the synthesis. Open run. So we are using this board. Okay. Yeah. So show the schematic. I mean, it will show only the logic cells only. Okay. It will show the logic cells only. Just if you want the particular circuit reports, get cells. I don't. You don't give anything. Just a minute. Report. Timing. So now it will give the timing records, so we need to wait for some time. Yeah. So it will give the maximum paths and how many. This is the combination circuit. Okay. So there is nothing but maximum of worst delay and slack also. So this is the timing report checking, and you need to check the utilization also. You need to check the utilization also. Just a minute. You need to do the normal command of utilize. Yeah. So in this board, they have number of contents here. Okay, they have number of memories, DSP slices. So in the slice LUT, in the main slice, they are using only the one slice. Okay. So this is the clock generation. We did not use any kind of clock here. So it will give that we did not use any kind of memory DSP blocks. So I will show it in where which we are using. See, only we are using 3 input buffers, 2 output buffers, and 2 LUT3s. So this is the information of primitives. And of course, now I will run the implementation. Okay, we need to check that. Launch implementation. See, just a minute. See, after synthesis, we need to check the implementation also. After synthesis, we need to check the implementation also. So this is the launch run implementation. Yeah, it will give the netlist details. And now I'm give the main command. Wait on run. Don't worry, I will give the all comments. Okay, what I'm written here. I will explain everything. I mean, I will explain the DRC reports and routing reports also. There is only one thing is finally, after implementation, there is only one program and debug related to hardware. So after this process, I will connect the hardware, okay? And I will explain the interfacing of hardware. How can we connect the hardware? In using web, first of all, I will show it in Vivado. After, I will show it in TCS scripting. Okay. Otherwise, we will move directly to TCS scripting. That's it. Yeah. So here they are doing the routing and DRC, I mean design rule checking. Okay. So here we are doing the placing, routing, all these things. Okay. All of you. So here in this implementation, we are doing the reports, routing status, timing status of the full adder. And they're checking the multi-threading also. And so we need to move to bitstream. So the third one, see, this is the design source is the main file. And of course, simulation source is the test bench file. And the main one and the major one to related to hardware constraints. That is bitstream file. Okay, this is the constraint XDC file. See, how can I connect it? I will show the board just a minute. I will display the board. So this board I'm using here. This is the Edge Arctic 7. I think, is this visible to you? All of you. So first of all, I'm using the Vivado. Don't worry. I'm using the Vivado. All of you. So just of all, if you've done the synthesis, you can click on the 5 input output ports. So now it will be visible here and do the maximization. Okay. So this is the total information of that package pins and input output standard. Okay, so here this is my board XC7A35T2561. So you can verify that. You can zoom and verify that with number XC7A35T FTG2561. Okay, so how can we dump the Verilog code? So we need to connect the inputs to the switches. I'm using the switches and LEDs for my input output verification. Okay, for this particular input output verification, I'm using the switches and LEDs. Okay, I'm using the switches and LEDs. So that is our wish. We need to use any kind of switches, no problem. Suppose I want these three switches. See in the left side of the board. We want this particular switches for in one, for A, B, and carry in. I want these two particular LEDs or these two or middle of the two. No problem. You can select any one. Okay. So you can zoom it and check one thing. So if you want this switch for A, how can we connect it? That is the major problem. How can we connect it? So simply you can notice the package pin name here. Not the SW18, switch 18. That is the name. M6 is there. Is it visible to you? M6. I think this is the visible. M6 is there. That is the pin number. See, you can type the pin number here. M6. That's it. The pin was selected to the A. So same thing, you have to follow the same process. So the second switch for B. So same thing for N6. So don't connect the other pins. Don't connect the random pins. Okay, that will become confused to you. N6. See, now we are connecting that. N6. So this is using Weber tool. How can we connect the board? Not in a TCS scripting. Okay. First of all, we have to do it in the Vivado. And of course, the third switch, P8. The P8. Here I'm connecting the P8 to the carry in. Okay. So and sum and carry, you can connect these are the outputs. See, in the direction will be show it whether which one is input and output ports. Okay, so these three inputs I'm connecting the switches. So don't connect the output to the switches. Okay, you have to connect the LEDs. We have to check the LEDs. This binary output, sum and carry. We have to connect the LED pins with the verification of the binary outputs. So I'm using this. These two LEDs. No, this two is better because of this ABC and sum and carry. This one is good. So now I'm zooming this one. So I want this LED for sum. So the number is T9. Okay, the package pin is T9. So the T9. And the second one is this is the Cout for the T10. See, if you not only for this board, if you use any kind of board, this is the process. Same, but the pin numbers will be changing that according to the board. According to the board, the package pins will be changed in that. This pins is only for the edge board. If you move to the Nexus A7 or Basis 3 or D10 Nano, definitely the package pins will be also changing that. Okay, so I'm done everything. I'm fixed the all pins. So now we need to change the input output standard into the LV-CMOS 33. Okay. So click on the control plus yes. See, this is the XDC file. So XDC means the Xilinx design constants. Xilinx, X means Xilinx, the company name. Xilinx design constants. Okay, DC means design constants. So now I'm giving FA, just normal. You can give any name, no problem. This is using software, not the TCS scripting. See here. Now we can find this code. Okay, We are finding this code. See which pins we are connected here. We are finding the XDC code. This is the XDC code. Sir, we have some small doubts, sir. In the TCS scripting, we did not connect the pins. How can we connect the pins? There is nothing to chance to connect the pins. You have to write this code. You have to see how can we write the Verilog code and test bench code, and you can open the file and you have to copy paste this code. You have to write this XDC code also. That is mandatory for the industry persons. You have to write the XDC code. Okay, including pins LVCMOS 33 input output standard. Okay, so you have to write the XDC code in the same manner. How can we write the main code? See, how can we write the test bench code? I will show it. See this one. How can we write the main code? How can I write the main code? Creating the file and open it and writing the code and close. So same process you have to follow for the XDC also. You have to do the copy paste this code into TCS scripting. There is nothing to connect the pins. Okay. So now connecting this program and debug, click on the generate bitstream. Click on the generate bitstream and now click on OK. So I will open the camera and I will show the output. Okay, no need to worry about it. Just a minute. I will connect my camera. So this is running here. No need to worry. We have to wait for 1 or 2 minutes. This synthesis design. I mean, we are running the synthesis routing, placing, all things will be running here. It will take 1 or 2 times. I will connect the hardware board to my laptop. Just a minute. So it will take much of time because of it is running the routing and placing design. Okay, all of you. Yeah, now it is writing the generate bitstream. Just a minute.
Hello. Hello, sir.
Yeah. So now it will be done. So we are in final stage of connecting the hardware. So now I'm connecting my board to my system. So you can click on the Open Hardware Manager. See, you can click on the Open Hardware Manager. Okay. So it will give the open target, this option. So this open target option will be checking whether our board is connected or not to our laptop. Okay. Just a minute. I will open my cam. Is it visible or not? So this is my FPGA board, what we are connecting. And now all of you please see this one. So now we can click on the open target, auto connect. So whether it is checking our FPGA board connected or not to my laptop. So if it is again giving the open target, so definitely it will be failed. So we need to check the cable type here. So we need to check, click it on open target again, auto connect. Just a minute. See, now it will be changing. See, now it will give the program device. Okay, so if my FPGA board is successfully connected to my laptop. Okay. So if you move the FPGA board, definitely it will be give the wrong kind of errors. So we need to connect the FPGA board again and again. Yeah. So the program device. So simply program. See, this is the bit file. This is the main bit file. We need to dump that. Click on the program. Now successfully this full add program will be successfully dumped in my that.
Hello, sir.
Yeah, please.
Sir, when it is possible everything to do through the GUI mode using the Vivado.
Yeah. Yeah.
So
Yes, it is for.
I want to understand why is that you are giving the demo through the command mode.
Yeah, the geoscripting is the very easy method. I mean, definitely everything will be understood, but the TCL is the main one. Just a minute. So now I'm successfully done the Verilog code. This LED was blinking here. This is the done LED. Okay, so this LED was blinking. Now my code will be successfully dumped into this Edge Arctic 7 FPGA board. Okay, so you already see that program devising program. So these three are my full adder inputs. We are selecting the three switches. You people are know about it very well. See, use and these two are my output LEDs. So now I am giving the 001. So this is the full adder verification. I mean, just a minute. Switches was not working properly. Okay, don't worry. In the TC scripting, I will show the full adder verification. This left switch will be not working perfectly. Okay, so that's why it is not working. There's nothing will be changing here. Okay, for 001, the sum will be on, but this switch will be on in this both. So in the TCS scripting, I think you understand the process. How can we dump the Verilog code? That is enough. Okay, that is the switch problem. Okay, the sliding switches was not working properly. Okay, so I think you people are understood how can we dump the Verilog code, all of you. So now we need to do that same hardware process in the using TCS scripting. Okay, don't worry, I will continue it in the tomorrow class, all of you. So, so same process. How can we do that? We need to write the Verilog code. We need to write the code for HDC. We need to write the code for HDC. So I will, shall I send the comments to you? Anyone, if you want to interest to do the TCS scripting, I will send the comments to you. Okay, up to implementation. So we are done up to implementation. After tomorrow, I will continue from the bitstream. Okay, so we are done the TCS scripting up to implementation. Only the hardware will be remaining. Of course, I will explain today this how can we handle the hardware. Okay.
Sir, my question, can you please answer, sir?
Yeah, please, sir.
Sir, when it is possible using the VADA, everything to do from RTL to bitstream generation and then configuring the hardware, what is the point of adopting the command line, TCL based?
TCL based.
Yes.
Yes, sir. I mean, using GA scripting, it's a good one, showing the image output, and that's the good one point. But according to from coming to the industry standards, so definitely they are giving the major to this TCS scripting only. Because of the much of outputs, they will give the every possibility of outputs also. Suppose we will see the simulations. If the simulation, suppose we will check the simulation, it will give only the few possibilities. This is a small program. Leave this full adder. Suppose we are writing the Verilog code for the FIFO, synchronous FIFO. If you do the simulations, so definitely they will give only the few possibilities. Definitely they will give up to limited outputs only.
You mean through GUI?
I mean, using GUI also.
Limited possibilities through GUI. Do you mean that?
Yeah, of course. I mean, the GUI will show, I mean, hello? Yeah, the GUI will show the simulation output in the image representation. If you use the TCS scripting, definitely it will be the good standard of the students also. For this is related to the industry standard. Of course, I mean, up to, I mean, not only TCS scripting, only for the Vivada tool. Of course, the Vivada tool, they have GS scripting is there. If you move to the system Verilog, if you need to handle the model sim tool or Questa sim is there. Definitely, you need to handle the tools of using command prompt also. You need to, that is mandatory to use the TCS scripting, TCL commands also.
Okay.
Yeah. Yeah, anyone have any doubts? I mean, can you please ask me? Yeah, today we will give the feedback link, Sridhar sir.
Yeah, so dear faculty, feedback, don't worry about feedback.
Sir, today's command, if you can able to share in the group or by some means, we will practice.
Yeah, definitely, sir. I will share the notepad file.
That will add up.
Yeah, definitely. I will share up to simulation, up to implementation. We are done in TCS scripting.
Yes,
Definitely.
sir. Yes, sir.
Yeah, definitely. I will share the notepad file. Notepad
Okay,
file.
thank you.
Yeah.
Thank you.
Yeah. Tej, 1 minute, Tej. Yeah. Dear faculty, don't worry about feedback link. Feedback link will be shared every 3 days. Okay. So tomorrow we are going to share the feedback link. And coming to attendance, it will be auto tracked, no issue. Yeah. And regarding recording sessions, please find the link which I have posted in the chat box. And the link will be shared through mail also. Please check your mail once. And one more thing, we are going to share these presentations in the drive folder in through mail tomorrow. Okay, you can access the presentations also. No issue. And we are happy. Like one more thing, a small announcement, my dear faculty. So as we are stepping into 4th year of our company establishment, we as a society every year doing a CSR kind of activity, that is scholarship exam for the students with worth of 2 lakhs rupees. So we are conducting scholarship exam and providing prizes for the top performers, internship opportunities for the top students, especially for students. So this year also we are going to launch the scholarship exam. So I kindly request, share the information which is going to be shared in your groups to your students, those who are in need, or else those who are those who are highly talented, or those who are interested to do work in core domain. Yeah. So everything. Yeah. This is all about the scholarship exam we are going to launch by this weekend. That's it for today. So we are expecting your if generally we believe that if a company is growing means it's the efforts of the not only employees, not only the core team. We believe that the well wishers, the partners, the stakeholders, that is you. We believe our faculty members as our stakeholders. So we request you to just we request you to share this information to the students. Soon we'll launch the scholarship exam 2026. Thank you for the time. Tej, please continue with the doubts and wind up the session.
The switches are limited. I mean, Kavita Veerapan. The switches are only 16 switches based upon the board. There are 16 switches in my Edge RTX 7. So if you want to use the more, there is also a push buttons is there. Okay. Yeah, there are limited one. Yeah, definitely I will share the code. Yeah, Deepika, GUI scripting is also where, yeah, reports like timing, but quality. But quality, the TCL will be maintained some quality. That's it. In one word, I am saying that the TCL will be maintaining the quality of the reports. So you are already saw that many kind of these things. I mean, this is the small program. This is just an example. If you do the maximum, if you do the protocols or any kind of serialization, deserialization protocols, then you can get the more informational. So then you can get the differences. How the GUI scripting will be given the outputs, how the TCS scripting will be given the outputs. That's it. Of course, the report generation quality and reproducibility. And for result accuracy, definitely they both are same. Which processor, madam? Adilakshmi, madam, which processor? Okay, you're asking about the GUI. Vivado, I mean, to connecting hardware or anything like that. Yeah, definitely. I will repeat the tomorrow. Okay, no need to worry about it. I'll share the process also. Okay. I will explain that. How can we interface the hardware to the Vivado using TCS scripting and both Vivado. See, this kind of results I mean, yes, absolutely. The power area means, I mean, utilization. The timing results are both in Vivado and TCL, but you need to, I mean, the GUI is the front end, but the TCL is the command line front end. Okay. And yeah, of course, I mean, they're both giving the TCL and GUI, they're giving the same kind of power area and timings. I mean, I'm comparing the GA and TCL. The reports, I mean, this power and area are both are same in that. Yeah, I will share the comments, madam. I will share the up to simulation, up to implementation. We are done that. Definitely, I will share the comments. Okay, no need to worry about it. Definitely, you can do the maximization of program. Definitely. I mean, yeah, if you, I mean, anyone have any doubts, you can contact me in WhatsApp. I don't have any problem. So I think I'm in also in, I mean, this. I will share my mail. Just a minute. Send.in. So this is, yeah. So this is my mail. You can contact me at any time. I don't have any problem. With reasonable doubts, or if you want any kind of project ideas, also I have many kind of project ideas is there. I mean, application oriented or memory oriented. Majorly, we are working on the memory oriented projects. That's why memory and protocol communication projects. That's it. Yeah. So if any, I mean, if your doubts are clarified, then I will leave at your convenience.
Thank you, faculty. We'll wind up the session here. We'll again meet on tomorrow's session. Bye bye. Have a nice day.